Capacity planning for the coming year is completed. As a final step, you'll look at the VM options and perform non-abstract cost optimization analysis. Given the growing capacity requirements, would it make sense financially to choose a bigger capacity VM, or is sticking with the current size VM the most cost-effective?
So now let's go ahead and optimize for cost and capacity on our photo application, and let's just ask ourselves, can we offer the same service for less money? At some point, that's how you make more money. If you can't drive more customers, you drive down a lower cost for your infrastructure. So here we are, it's about a year. We have to create a new budget. So the reports are in from last year. The forecasts are all done, and now the recommendation is to go for approval. But there's one thing that we need to do before submitting this recommendation. We have to ask ourselves, could we save money by perhaps moving the current upload instances, which are N1 Standard 1s to N1 Standard 4s? And of course, we could apply this to our entire service set, but let's just take one example and move with that. Remember, be careful, the number of cores also changes the network throughput and disk characteristics. So we may benefit if we're in a high throughput situation in which we weren't enabled, say with an N1 Standard 1. So here's a quick review, right? Can we actually optimize these upload servers by reducing the quantity and increasing the number of cores? So here we are. In this case here, the current upload VMs, they're N1 Standard 1s. They're one CPU running Debian 9 OS, so it's a free OS. In this case here, our monitoring peak pool was maxed out about 576 machines. So we have to kind of use that as our standard. Our PerfKit benchmarker indicates that current performance of an N1 Standard 1 comes in at 1.4 gigabits per second, while an N1 Standard 4 is 6.1. So right there you can see there's some network efficiency being driven by upgrading to 4 CPUs. In fact, we may not want to stop there. We may want to try the entire spectrum. But here's the process. We basically want to make a recommendation, should we move to higher core CPUs? Now from a network standpoint, that sounds good, but we may or may not be utilizing it. So let's see if there's any cost effectiveness. So here's how it works. With our peak of 576 servers, we've already established our throughput for those servers with PerfKit. So that basically comes out to 806 gigabit peak per second. Now, if we actually take a look at the PerfKit benchmark for the N1 Standard 4s, we can achieve the same results, the same throughput, with 132 instances. Now let's go to the Google Cloud Calculator, and in this case we can see the cost for 576 single core machines versus 132 quad core actually come in with about a $1,100 price difference. So that's almost $12,000 per year. Now sure, there's a little bit of work in actually adjusting and optimizing these, but as an auto scaling template, this would be very easy to do. It's not like you're updating all machines. You're actually updating one template and updating your auto scaling instance, managed instance group. So actually this would be quite trivial, and we could start saving money immediately within the first 30 days.